Right, this is day one for both MAP4C and MCT4C, lesson 1.0, which is the Trig review, and also our first video of the year. So welcome. The 3-minute review here. We see the goal is to identify, name angles and sides of a triangle. So in this triangle here, we've got a bunch of stuff on it, and we want to be able to just refer to the angles and sides in two different ways. So for instance, this side is 4 centimeters there, and we can label it with two ways. The opposite letter, angle M actually, but we can label this side as little m, but also as this line segment NP, and that's the 4 centimeter side. We'll just keep going here. Little n is this side, which is MP, which is 3 centimeters. Finally, side P, that side there, the 5 centimeter side, is MN, capital M, capital N, and 5 centimeters. Angles, on the other hand, can be labeled in two ways. One with just the letter. Okay, that's a decent angle sign there. Angle M is 53 degrees, but we can also label it with 3 letters, with M being the middle one. PMN, for instance. And that's 53 degrees. Next, N, angle N. We see here's 37, but it can be also labeled with 3 letters, MNP. Oops. MNP, which is 37 degrees. Notice that MNP and PNM label the same angle, so that would be okay if, you know, MNP and PNM, they're the same thing. Lastly, angle P, MPN, and of course that little symbol means that that's our 90-degree angle. Okay, that's it for the 3-minute review. Give yourself a rating, pause the video, and I'm going to get going on the lesson. The lesson is just trig review. Identify primary trig ratios in right triangles. This is review for everyone of grade 10 and grade 11 stuff. In a triangle like this, we talk about the relationships between sides and give them names. Sine, cosine, tan, and depending on which trig ratio we want, it's the ratio of 2 of these sides. How we label the sides depends on which angle we have a reference to. So for instance, here's angle theta, and that gives us the opposite side and adjacent side. These names kind of make sense. It's opposite through the triangle, and this side is adjacent next to angle theta, so that kind of makes sense. The hypotenuse is always the easiest one to name, because it's always being pointed at by the 90-degree angle. That one's always the hypotenuse, but depending on which angle we're talking about, the opposite and adjacent sides can switch places. So from this angle, opposite and adjacent sides are these ones that are labeled here. And of course the sine, if we remember our grade 10 stuff, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Whoops. What happened? Oops. Let me just erase that. That's kind of a mess. Very much better. Adjacent over hypotenuse. And tangent is opposite over adjacent. And of course, we remember these ratios with the little memory aid SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, SOHCAHTOA. That helps us remember which trig ratio gives us which relationship of sides. And here's some examples. So for instance, the sine of B, we're talking this angle. Remember, the 90-degree angle points at the hypotenuse. So that one's always the hypotenuse. But from this angle, this is the opposite side. And we remember the sine from SOHCAHTOA. 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 Sine is opposite over hypotenuse. So opposite over hypotenuse is this side over this side, AC over BC. And I've labeled it with the line segments like this, but we could use the little letters, little b over little a, if we wanted to be a little bit lazy, I suppose. I'm going to use a different color for part B here, just so we can see how it changes. Because now, if we're talking from angle C, this is still the hypotenuse, but the adjacent side, this side that's next to it, is this one, isn't it? And this is the opposite side. So the cosine is adjacent over hypotenuse, adjacent over hypotenuse. This side over this side is AC over BC again. And that's just coincidence. So it's the same as part A. B over little a. Finally, the tangent of B, and I'm going to erase that again just so we can fresh perspective here. From angle B, tangent is the opposite over the adjacent. Right? This is still the hypotenuse, but we don't really care. It's the tangent. Opposite over adjacent is AC over AB. And in little letters, if we like, B over C. Last example. This time our triangle's got numbers on the sides, but you know, all we have to do is state the ratio, so this shouldn't be too big of a deal. Make my line a little smaller here. The sine of P is, this is the angle that we're talking about there. Sine is opposite over hypotenuse, 0.8 over 1.2. Just a ratio of sides. These are just numbers, and we could fire that into a calculator if we wanted to. It didn't ask us to find out what side or angle P is, but you know, it just wanted us to state the ratios, and if we wanted to get a number there, we could. Cos of P is adjacent over hypotenuse. Adjacent over hypotenuse. And again, if we'd like a value, that's 0.3 repeater. And again, doesn't matter. Don't need to find out what angle P is. That's tomorrow probably, right? Tan of P from angle P, opposite over adjacent. And that is 0.8 repeater, which is about 0.9, eh? But that's it. We don't have to find angle P. We don't have to solve any problems. This is it. This is all we're expected to do today. So that's it.